Thanks for coming to my talk. If you came to my talk yesterday, this talk expands on what we talked about yesterday. It goes into in-depth detail. I'm going to show you packet traces. This is the nitty-gritty details. Also, coming to this talk, you should have attended William's talk previously about OAuth Part 1, OAuth 2. This expands on his talk and goes over some of Microsoft's extensions to OAuth 2. But if you didn't watch the previous talk, you can go back and watch the recording. So I thought I'd list some of the acronyms and terms that are used because, like I said yesterday, it's kind of an alphabet soup of acronyms, and if you're not familiar with what I'm talking about, you can kind of get lost. A couple of them are obvious. A PRT is a primary refresh token, which is it's used for SSO. That's the easy way to explain it. You can use it for single sign-on to other applications, to the browser, etc. And on behalf of flow, OBO is a token flow for delegating access. It's a short form of it. NGC, you'll see a couple of times, is next generation credentials. You'll see this a lot in relation to Hello for Business keys. Hello for Business is Microsoft's branding for basically key authentication. So you register a certificate with a private key stored in a TPM, and the public key is associated with the certificate. And, well, you register it by sending a certificate signing request, and Microsoft will send you a signed certificate, and you use that in authenticating the device. TPM and HSM, these are related to, TPM is a trusted hardware platform-backed module, and HSM is a software version of the same thing. JWT is a JSON web token. This is something you'll use a lot in web terminology and such. This is something that we use frequently in OAuth 2 to perform authentications to prove ownership of tokens and such. I think I'll skip over the rest of these, but they're useful to know what those are. So a brief introduction. This is where we started. A recap of the previous talk. A reminder that OAuth 2 is only an authorization framework. It does not provide authentication at all. And so any authentication in a supposed OAuth 2 system is actually an extension. OAuth 2 defines flows to obtain access tokens for resource APIs. It leaves authentication up to the implementation. The common grants, or as William pointed out, the safe grants to use are authorization code, device code, and client credentials. And then vendors tend to implement lots of their own extensions. Microsoft supports many other grant types, but most of them are not really safe to use. So this session is to pick up where William left off. So I'll start off with this. William pointed out this OAuth 2 terminology, where your things that you would typically expect to be named one way have been renamed by OAuth 2, where, for example, your machine sitting in front of you is going to be called the resource owner instead of a user or a browser. The identity provider is called the authorization server. The server or service that you're contacting is referred to as the client. This is the most confusing part, in my opinion. And then the actual resource, the database or API, is called a resource server. So Microsoft decided that this wasn't confusing enough, so they renamed two of them. And actually, I think this is a little less confusing in my opinion. But Microsoft refers to the machine sitting in front of you. Instead of a resource owner, it refers to it as a client, from my experience. And then they tend to refer to the service or the supposed client as a resource. And then you have your resource server still in the back end and your authorization server. So when I use these different terminologies in my presentation, do not confuse them with the names that William used in his presentation, because Microsoft refers to them differently. And out of convention, I will refer to them the same way as Microsoft does. So the extensions and topics that we're going to cover today is Microsoft's extensions. First off, I'll cover briefly their core extensions. The core extensions are mostly OIDC. Apparently, Microsoft hired some of the developers that introduced OIDC and then called it something else. Then I'll introduce the broker client extensions. This is probably the most extreme divergence from OAuth 2, and the most important part of Microsoft's identity management, I think. That'll cover things like PRT issuance and such. I'll talk about the enrollment extensions, which is not documented at all. There were several actually on-prem documents for Windows Server that are similar, but they're completely wrong. And I documented this in my own project so that others could get an idea of how it works, but otherwise it's not documented. And then finally, we'll talk about Microsoft's undocumented authentication flow. And we'll talk about details about the broker client. And see here, we're calling it a client again, but this is the device in front of you. This is not referring to the resource, as Microsoft refers to it. We'll talk about how it works and so on, and how it's implemented in Himmelblau. So Microsoft's extensions change some of the core assumptions about the protocol. The broker architecture, it introduces lots of extra client-side stuff, important parts for SSO, device binding, and so on. And like I said, most of it's undocumented, proprietary, and inconsistently implemented. So this should enable you guys to be able to understand how to do the implementation, essentially, and maybe help you to diagnose and resolve issues. So let's talk first about the authentication flow. So I'm going to use a passwordless example in this talk. There are many different paths in the authentication flow. This is just one of them. All of these flows are managed through OAuth 2 endpoints. There are some other endpoints that we'll talk about. Also, something to keep in mind is that there are multiple definitions for the term passwordless. Microsoft, in this case, is referring specifically to the authentication through the Microsoft Authenticator app without a password. And that is something you enable on the application. So the first step in the authentication flow, and this is a common step among all of them, is that you send an initial request to authorize to the authorize endpoint on the OAuth 2 server. And there's a couple of extra parameters here that you don't usually see. For example, the AMR values specifies here that we want to receive a next generation credential MFA token, which forces the user to authenticate with MFA. The response to this request will be an HTML page with some embedded JavaScript, and that embedded JavaScript is what tells us how to proceed with the authentication. So I extract that JavaScript variable, it's called the config, which holds an authentication state. It contains URLs to proceed with the authentication, various options. It has it has like threads that help that can be used throughout the authentication process, such as the flow token, etc. After receiving that response and storing all of those URLs that we'll use during the authentication, we send it what's called a get credential type. I found out recently that Microsoft started stuffing this in the initial authorize, so this is now optional. I haven't modified my code to account for that yet. I just sent another request. The get credential type sends a response that lets us know. In this case, it has lots of important information, but for us, it tells us whether or not, for example, it has a password assigned to the account. It also tells us if the authenticator app is configured for passwordless authentication. And if it is, it'll have this remote NGC params, which will help us perform the passwordless authentication. And this is what the response looks like. This is kind of small, but I wanted to show you. So there's the has remote NGC. Here's the params for the remote NGC. Here you'll see there's this entropy code. That entropy code is what we'll be plugging into the Microsoft Authenticator app to authenticate the user. There's also, you can see the flow token. There's a canary. These are both used, and the session identifier, those are all used in conjunction throughout the authentication process. You can see also here this if exists result. This is useful. This is how you enumerate users. When you send this get credential type request, it responds whether or not the user exists. Now this sometimes lies. So the if exists result, 0 means that the user exists, and 1 means that the user does not exist in the directory, unless they've disabled enumeration on the tenant, in which case this will always return 0. I ran into one user who discovered that no matter what username he entered in to the getEnt password, it always said that the user exists. And I was doing CN name mapping, just a second. I was doing CN name mapping, and so they could plug in any name, and it would append the domain, and it said the user exists, including local users, which was a problem. Yeah?
I just want to confirm. So this is all part of HTML page?
This is actually a JSON response.
Okay, but the previous page was not supposed to go, like you go manually to this get credential type.
Yeah, this is an HTML page that I've scraped the config off.
Without any notice.
Yep, which is why we have the device authorization grant option. And that's why I'm requesting Microsoft document this, so that we have some explanation and some assurance that this isn't going to change. So some of the calls are pretty straightforward, like this get credential type, and you know you're going to get a formatted JSON response. But others are not so certain. All right, so the next step is to initiate the password prompt. Now this URL here, this get one-time code, this was a URL specified in that config JSON blob that we got during the authorize request. I'll also point out, someone else mentioned this. This is not related to a device authorization grant, but it looks an awful lot like it. So we send this get one-time code message to Microsoft, and we will pull, if you remember the device authorization grant from William's talk, we will pull by sending this request over and over again, and until we get back the desired response. When we send this, Microsoft will trigger a authenticator push to your cell phone, and we need to prompt them with that entropy code that we got earlier. And then the user will be asked to insert that entropy code into their app. We'll continue polling until we get a status response. Oh, the get one-time code is the start of the poll, and then I just point this out. The next prompt is get a device code status. Again, not at all related to device authorization grant, even though it looks like it. And we'll continue to poll every 5 seconds or so, I think is the recommended by Microsoft. The state of 0 means we're waiting. State of 1 means that the authorization was denied. And a state of 2 means that the authorization was approved. At this point, and I'll also point out that this particular message, this flow, is not actually a website that we're scraping. This is a very standard, as expected, sort of flow. We're listening for a JSON response. So it varies. Some of the responses are very are formatted in very much what you would expect, and others are HTML pages. The final step is to complete the login process by calling, sending a post request to this endpoint, this login endpoint, which is also fetched from that config variable that we scraped from the original page, the original authorize. And we'll send the session identifier, the entropy that we provided earlier, and some other information. And this final step will actually respond with a redirect URI that contains our authorization code. And that response looks like this. And this is, of course, an HTML response that we have to parse. And the authorization code, if you look, is right there. Yeah, it's pretty long. Well, I'll go back for a second. So at this point, we can take this authorization code and we can continue with a regular OAuth flow, and we stuff this into a regular token request from OAuth 2, and we can utilize this authorization code to get an access token. So yeah, basically, we've got a number of undocumented steps. Some of them are in a expected standard way. Some of them are HTML pages with JavaScript injected with the config objects, and so on. Next, let's talk.
What's in the JavaScript?
Oh, did you miss that?
Yeah. Well,
Did I show it?
you show it, but Tom came a bit late.
Oh, I can go back for a second. Oh, that's not it.
Oh, I'm sorry. Don't go back.
I don't think I even showed it. I forgot to show you that.
Well, is it some important executable, or is it just?
It's a JSON blob
So
with a bunch of information in
no
it.
idea. It's just a blob.
Well, no, it's not. It contains a bunch of useful information as URLs.
Oh, so you can peek inside it.
Oh, yeah.
Productively. There's something interesting.
HTML page that has a bunch of JavaScript execution
Mhm.
code points.
And everything you need to know to perform the authentication is in this JSON object. And if we extract that JSON object, we can decipher how to proceed with the authentication. Okay, so the basics of the OAuth 2 protocol extensions. It has some of the core functions. This is mostly OIDC. nothing really special here. They add a couple of extra things like the target resource. Then we have these multi-resource refresh token, which is a refresh token that can be redeemed for an access token for any resource, which is kind of interesting. This is an image from William Brown. When I explained to him what this was, he kind of panicked. DRS is the device registration service for Entra ID. This is the first step in establishing your device identity. It's not officially documented by Microsoft, but of course it's crucial in order to enroll the device and to get device certificates, to gain a PRT, which is essential for your single sign-on and broker interactions, etc. Token issuance, token refresh, etc. There are a couple of related services. There's the discovery service, which tells you where all the URL endpoints are, and there's also there's a nonce service that you can discover. There's also a key registration service I didn't mention here, which is for Hello Key enrollment. The discovery endpoint up there, you can see it responds with various endpoints that you can call. The nonce endpoint just returns a nonce. It generates it for you. There's actually two different ways in an authentication to request a nonce. There's an alternative that Microsoft actually recommends and uses all over the place that does not use their nonce endpoint. I don't know why. But you can send a particular request to the token endpoint and request a nonce instead of using the nonce endpoint. A join request looks basically like this. You send a request to the enrollment server, which, by the way, the hello key enrollment is also sent to the enrollment server, but it's a slightly different URL. You send it a CSR in PKCS 10 format, and we send it a public transport key, of which we have the private key stored in a TPM, and then basic device info. There are optional TPM attestation options, which are not documented, and I do not know what format they need to go in, because these other ones are actually documented in Microsoft protocols, these top three. They're documented in protocols that are unrelated, but they're the same. So we know what they are and how they're formatted. But the TPM information is not documented anywhere. The
payload that's stored in the TPM.
what's that? I mean the attestation.
The payload that's stored in the TPM.
Yeah. The payload in the attestation. I mean, I know what a TPM attestation is, but I don't know the format to supply it to Microsoft. And that's critical because if you get the format wrong, it just rejects the request. Yeah. Yeah, exactly. There was some trial and error actually getting the CSR format correct.
But that's just a format problem, right?
Yeah. The attestation is a format problem also. I just don't know how to format it.
You
Yeah.
know what the payload should be, it's just hidden in the
Exactly.
format. Okay.
Yeah. The response is going to be a signed certificate, which is associated with your device enrollment. Inside of that certificate is a device object ID, which is the device ID stored in Entra ID. It'll also contain your user UPN and some membership info, which Microsoft explicitly tells us to ignore. I don't know why. And this is just a overview of kind of how it works. You can see we send the enrollment request, we get a response. We have to request an auth token. I was going to say that didn't make any sense. You send a request for an auth token that is for the enrollment resource. When you get the auth token back, you will use that in your enrollment request. You also need to generate a TPM-bound device key and then certificate signing request associated with a TPM-bound key. You could theoretically have the transport key over here that will derive. You could theoretically have the transport key and the device key be the same thing, but you shouldn't. They should be separate, which they are in Himmelblau. You can do you send the endpoint discovery and get a JSON response with all of the endpoints, and then we're going to send the request, which is forwarded on from Entra ID to a DRS service. That's why I call the protocol MS-DRS. That's undocumented because I know that it's being sent to this this cloud server called DRS, Azure DRS. Azure DRS will validate the token and such, and then generate a CSR, or they'll write a device object back to Azure Entra ID. Afterwards, we'll get the device certificate back. We'll associate that with our TPM bound key. And finally, you need to do MDM enrollment, which is not implemented in Himmelblau because I don't know how it works. But Alexander and Andreas had some ideas about that. I'll be working on that.
Documented?
No, not for Linux. It is heavily documented for Windows. It is completely undocumented for Linux.
Oh, okay.
Yeah.
Good, yeah.
They are platform dependent. There is separate for macOS, there is separate for Android, iOS.
Yeah.
Yep.
Yeah,
And
absolutely.
for Linux, they seem to be, there's nothing common, let's say.
Yeah, it's completely different protocol. I would say that the Windows, I'll point out that the Windows MDM enrollment protocol is using SOAP, and it's a very well-defined SOAP request. And I can tell that the...
It's not SOAP, it's called WSDL, I think, right?
Yeah, whatever. I know what you're talking about. Yeah. It's a subset of SOAP. You know what I mean?
Yeah.
Yeah. Anyway, and then the Android request is JSON. It's expecting a JSON request and response. I know that much. And the JSON request and response are nothing like any of the other protocols, I can tell. That's as much as I know from throwing garbage at the enrollment endpoint. And I can tell you that fuzzing the enrollment endpoint does not return any useful error messages. With a appropriate authenticated access token. Okay, so this is what a device enrollment request looks like. There's our CSR. It's base 64 encoded. There's our public transport key. And then there's these other options I didn't mention. Like, look here, I have my OS version set and as Ubuntu in this case. Oh, the join type is kind of interesting. I'm not really sure what all of the join type options mean. I have a vague idea of some of them based on the documented Windows protocols. But there are a number of join types that are completely undefined anywhere, but it accepts them, and I don't know what they mean. For example, we know from some Windows documentation that join types 1 through 4 are various things. I don't remember exactly. I'd have to pull up the document. But you also have join types 5 through 8, completely undocumented. I don't know what they do, but it accepts them. This is what the response looks like. There's the raw certificate and a thumbprint. And then it returns these SIDs, and the documentation that exists explicitly says, ignore this, it's garbage. Okay. It's not garbage. I don't know why they say to ignore it. I think the issue is that the responses may be unreliable. And when you decode this, it's actually the SIDs of I believe these are your groups that you're members of, and one of them was a device object or something like that. I can't remember. It is sensible information, but Microsoft says ignore it. It's not reliable, essentially.
So they are not stable mappings.
Apparently. Yeah. Okay, so we'll talk about the broker extensions now. The broker is a little hard to grasp. The concept is that it's this high-privileged client application that sits on the computer that manages your tokens. Windows has this, and they run a broker on Android, on iOS, in their software, whatever. It defines, the spec defines how a broker gets what's called a primary refresh token. A primary refresh token is different from a typical OAuth 2 refresh token in that it looks like a refresh token, but it has a much longer lifetime. Your typical refresh token lasts hours, if I remember right. A primary refresh token lasts at least 30 days, generally. And these need to be secured because these are dangerous. You don't want these to leak. You can exchange, the document explains how you exchange PRTs for access tokens, logon certificates, and then the document defines these custom headers. Device credential it proves that you're authenticating from your enrolled device. It's basically a JWT that is signed using your device credentials that we got when we enrolled. The refresh token credential is using the refresh token and signing it as well, using the session token in the PRT, because we have session information in the PRT. And then the SSO flags is defined, and the document says that it's implementation specific, and I've never actually seen it do anything. So maybe it will be used at some point. So the purpose of PRTs primarily is long-term authentication and renewal of tokens. Like I say here, it provides a way to maintain user authentication over an extended period. So for, I've only got 10 minutes left? Okay. I'll skip past some of this. It's important. It uses the PRT to request tokens and refresh tokens, manage user sessions. The way a PRT flow is you send a post to the token endpoint, the OAuth 2 token endpoint, and get a nonce. That's what the nonce request I was explaining earlier. We send a device credential and user credential to get the PRT, and this PRT in the end can be exchanged for access tokens, etc. I already said that. I don't remember why I must have duplicated that. Anyway, this is what the flow looks like. I'm going to go ahead and move on, and we can look at the packet itself. This is a PRT v2 request. There is a second version of PRT called a PRT v3. Interestingly enough, the TGT request is not implemented in PRT v3. So you can only request a TGT for on-prem and cloud Kerberos access using a PRT version 2. Microsoft says both versions are supported, and you can use either, but it is interesting that the version 3 is missing some implementation. These are not, and the two are not exchangeable or interchangeable. If you have anyway, I'll move on. The request here I wanted to point out is a JWT. I will show you the JWT on the next page, and then of course the TGT request. That flag just says, I want a TGT in the response. This is what the request JWT looks like. You specify a client ID. This particular client ID is the broker client. You've got your nonce, a set of scopes. I forget what these mean, but one of them means that you want a PRT response. That's what this means. My Windows version is OpenSUSE. Grant type. Now it's a primary refresh token, but we request it and specify that it's just a refresh token, and that's on purpose. This is what the response looks like. This is a PRT response. You'll see here, right here I have this error message saying the on-prem configuration is missing, so it could not send me a TGT. A TGT AD is what it would come up as. But it does have a TGT cloud, and this is encrypted and can only be decrypted using your device, a combination of your device keys and your session keys. And after you've decrypted that, then you can stash it in your Kerberos C cache. Here's the session key. It's the JWE means that it's a JWT that's encrypted, and you have to decrypt that in order to decrypt your TGD cloud, and etc. Here's your new primary refresh token right here, and then there's other details about how to configure your Kerberos with your TGT, and so on.
Does it send you details which KDC proxy to contact?
I think that's what is supposed to be in here, but when I've tried to KDC proxy using the details it supplies, it doesn't appear to be a proxy endpoint. So it appears to be a genuine Kerberos KDC. So I don't know why it behaves that way. And I think Steve Siffis said it was a proxy, but it hasn't worked. Anyway. So the difference is, we'll just skip over that. Let's talk about the broker. This is how Himmelblau implements the broker architecture. We have the daemon here. We have this DBus service that implements the user session requests, and then etc. We talked about a lot of this already. I'll briefly talk about this. So Canonical is misusing the term broker in their authd application. They refer to their service as providing a broker, and they also make claims about local password hello stuff. And the reality is it's all fluff and marketing. They don't actually implement any of this. Just a week and a half ago now, I think, 2 weeks ago, Canonical actually contacted me and said they're going to use Himmelblau as their backend. So the previous slide will no longer be true. They'll actually be telling you the truth, potentially. The core components. Yeah, I'll just skip past this since I'm running low on time. But what Himmelblau implements, we of course have PRT support, device enrollment. We generate the transport and session, and we store session keys in memory. Of course, we don't stash them. We have Windows Hello for business integration, and so on. The DBus service that Himmelblau provides actually mirrors Microsoft's DBus service called their identity broker. This is intentional because there was already a Firefox and Chrome browser extensions. There were already those created by Siemens, which integrated with Microsoft's DBus service. And so I implemented the same DBus service and provide those tokens to their browser plugins, and that gives us SSO. I'm going to go ahead and skip past that. I'm going to skip on, and we'll go through the walkthrough, the brief walkthrough, at least part of it, and we'll have time. So you would have seen some of this before. I just entered the username, and it started the passwordless authentication flow. You can see it's polling right now while I enter that entropy code. That's 79 sitting there. You can see the device code status poll, and then I did the authorize and the get credential type.
You haven't even entered the username, or that's the username?
I typed in the username right at the beginning. It just enrolled the device down there, and now it's enrolling a Windows Hello key. If you look back over here, you'll see the Hello pin enrollment. That's the enrollment happening. Down at the bottom, it said enrollment server key. It just downloaded the profile photo. And In a second here, it'll expand the window so we can see those packets a little better. There we go. So there's that get credential type request. And the authorize with the, that's an initial authorize that I sent specifically to check some details about the authentication. There's the one for the NGC to begin the MFA request. And then the response, that is what that config variable looks like. And it's a big JSON blob. And then the get credential type, that's the get one-time code request. We could theoretically implement some of these steps without the browser parsing and such. At the end, you see authorization state 2, which means that the authentication was approved by the, oh, I'm over time now. Okay. Do we have any questions? I'll let that keep playing for a moment.
So the library itself implements all of this logic, except talking to PAM and NSS parts. That's the part of the daemon.
Yep.
So technically, we can use the library and front-end PAM and NSS with different methods like SSSD. It should be cleanly integratable, right?
Exactly.
Okay.
Yeah, there's, I have some example code that you could see that in the library that shows you how to integrate with it and how to perform an MFA flow without, I mean, there's no requirement other than just integrating these flow controls.
Okay. The concern I have is that because this is the original one, you get the HTML page.
Yep.
That is unreliable thing.
Mm-hmm.
So the only thing we rely from it is the C data with the config.
Mm-hmm.
As long as that one stays somewhere in the HTML page, we would be able to proceed. Is the parsing for that hard-coded in the library?
Yeah. Yeah, it's all done in the library already.
My main question is, how can we quickly adjust?
Quickly adjust if it were to change.
If they change something there, we should be able to adjust. Otherwise, it's flat denial on any authentication.
That's a good point, and we can work on that. Yeah. Yeah.
So when you say there's already browser extensions talking to the broker, does the broker hand out the PRT, or are the extensions requesting the broker to get the access tokens for them on behalf of them?
It's requesting that the broker get the access tokens for them. Yeah. Also, the way I've implemented the MFA flow, it will automatically fall back to a device authorization grant seamlessly to the user. So, by the user I mean the implementer a daemon, for example, or the implementer of PAM. So when you call into the MFA code, it assumes that you want to use the back-end MFA flow, and if something fails, it will record an error and drop out by responding with a device authorization grant URL. And that's how we're handling it, so that it's seamless to the user. Officially, we support the device authorization grant, and if this flow works, then it's simpler and seamless, more seamless to the user. But if that flow does not work, it falls out and just requires a device authorization grant. Completely seamless. Yeah.
If Canonical picks this up, A, is that a good thing for you, I assume?
I think so.
And B, how do you see this putting pressure on Microsoft to open up the support of this in a more public, stable way?
I don't know that it is putting pressure on them.
That's the risk here, right?
Mhm.
That they've held back information. Why? You know, is something going to change, or is this just,
I don't know.
you don't know?
I don't know. In some of our, when's the next talk?
That's now. Actually.
It's right now.
It's done now.
We're going to talk later. Okay. Thank you.